In this video, I'm going to do some titration calculations used to identify an unknown. When you're trying to identify an unknown, ultimately, you're going to try and find the relative formula mass. Once you know the relative formula mass, you should be able to work backwards and work out what you've got. So in this case, I've got an unknown carbonate. If I know the formula mass of the entire thing, I'll be able to work backwards and get the formula mass of X and then work out what X must be. In these questions, you're often given quite a lot of information. So at the start of the question, I'm told about how I make up the solution of my unknown carbonate. And then at the end of the question, I'm told about the titration itself. It's the titration that I'm always going to start with. So if I look at the titration, I know I've got an unknown carbonate and that 25 centimetres cubed of that was used into titration. So I'm going to start by writing this out as an equation. So I know I've got an unknown carbonate with the formula X2CO3, and I know in the titration 25 centimetres cubed of that carbonate was used. If I go back to my question, what am I titrating my carbonate against? Well, it tells me here that it's HCl, so that's the acid. So a metal carbonate would be a base. I'm titrating it against an acid. And again, if I look at the question, I'll find the volume of the acid and the concentration of the acid that was used in the titration. So I'm titrating my carbonate against HCl. I've got 22.4 centimetres cubed of the HCl, and the concentration of that acid is 0.100 moles per decimeters cubed. To fill in my titration table, though, I'm also going to need a ratio, and for that I'm going to need a balanced chemical equation. Just because you've got X instead of an element doesn't mean you can't finish this equation. If I look at the formula of my carbonate, I know that the carbonate ion has got a -2 charge. Therefore, the X must have a +1 charge. And I know that because I need 2X to cancel out the -2 on carbonate. Therefore, each X must have a +1 charge. 2 of them gives me +2. That cancels out the -2 on the carbonate. So if I know X is a metal with a +1 charge, when I'm writing the formula of X combined with chlorine, it's just going to be XCl. So X has a +1 charge, chlorine has a -1 charge, the formula is just XCl. Because this is an acid-base neutralization reaction, as well as forming that salt, I'm going to form water, and I'm going to form CO2 because it's a carbonate base. And then I'm going to need to go back and balance. I've got 2X on the left, so I need 2 on the right. 2 chlorines now on the right, so I need 2 on the left, and other than that, it is going to be balanced. So now that I've got all of that information, I've got my balanced chemical equation, I've got my volumes and my concentration picked out of the question, I can put all of this into my moles table, which I've done here. So I've filled in the volumes, first converting to decimeters cubed by dividing by 1000. I've got my volume, I've got my concentration, I multiply these two numbers together to work out my moles of HCl, and then I use the ratio from my balanced equation to work out the moles of my carbonate. Now, you could work out the concentration, but you don't really need it. What I've got now is I've got the number of moles of my carbonate in 25 centimetres cubed. Okay, so I've got the moles of my carbonate in 25 centimetres cubed. Now, I said that I wanted to find formula mass, and to find formula mass, I'm going to use my G Mr. Moles triangle. I've just worked out moles in 25 centimetres cubed, and I've got mass in the question. But if I look, the mass is per 250 centimetres cubed. So I've got mass per 250 centimetres cubed, and at the moment I've got moles per 25. I can't plug those numbers into the triangle until I've got them both per the same volume. So the easiest thing to do here is just to scale up by a factor of 10. If I want to know how many moles I've got in 250 centimetres cubed, 25 times 10 is 250, so I need to multiply my number of moles by 10 as well. Now I know the number of moles I have in 250 centimetres cubed. I know the mass I have in 250 centimetres cubed. I can now find formula mass. So the formula mass is going to be my mass divided by my moles. They're both per 250, and this is the formula mass of my carbonate. So the whole carbonate, X2CO3, is 106.25. But I need to work out what X is. Well, I can work out the formula mass of carbonate. That's going to be 60. So carbon is 12 and 3 oxygens, and adds another 48. So I know the carbonate is 60. I know the whole thing is 106.25. So to work out X2, it must be 106.25, so the whole formula mass minus the formula mass of the carbonate ion, and I'm left with 46.25. There are 2x, so if I divide by 2, I'll find the formula mass of 1x. X has a formula mass of 23. If I go to my periodic table and I'm looking for a metal that has a +1 charge, because I can see from my formula that X should have a +1 charge, a metal with a +1 charge that has a formula mass of 23, and the answer is sodium. So sodium, it's not 23.125, it's slightly off, but sodium is the metal that is closest to 23.125. So sodium is going to be my unknown metal, therefore my unknown carbonate is sodium carbonate. I'm going to do another one. So this is the next question that I've got. So this question again can feel maybe a little bit overwhelming. There's quite a lot of information in this question, and you've got water of crystallization, which I know is something that can throw some people off. But we're going to do this in exactly the same way as before. You're asked to identify an unknown. So you've got this hydrated sodium carbonate. You're trying to work out what N is. In other words, how many molecules of water are attached. And if I want to work out an unknown, I'm going to work out my relative formula mass. And if I want to work out relative formula mass, I need to use my G Mr. Moles triangle. Again, I've already got G, there it is, in the question, and I'm going to use this titration information to work out moles. So again, the titration information is typically at the end of the question, so it's at the end of the question that I'm going to start. And again, I first need to work out just what I'm titrating against what. So I'm told I've got these sodium carbonate crystals, okay? So it's just sodium carbonate with some water attached. And when I do the reaction between the sodium carbonate and the hydrochloric acid, that water is not going to be involved. It's the acid is going to react with the base. It's not going to react with the water. So when I'm writing my equation, I'm going to leave out the water for now. I'm just going to write sodium carbonate. Sodium carbonate reacts with HCl, because in the titration, these are the two things that will actually react with each other. It's an acid-base reaction. You're going to form a salt, water, and because it's a carbonate base, you're also going to form CO2. So the salt you're going to form is going to be NaCl. You're forming water, H2O, and you're forming carbon dioxide, CO2, because it's a carbonate base. To balance that, I need a 2 there, and I'll need a 2 there. I'm then going to go back, I'm going to pick out the relevant information from the question, all right? So the sodium carbonate, I have got 25 centimetres cubed of that sample, so I'm putting that into my conical flask using my pipette, so I've got 25 centimetres cubed, and then I am titrating that against, as we said, the hydrochloric acid. I'm given the concentration of the hydrochloric acid here, and I'm given the volume of the hydrochloric acid there. So my volume is 20 centimetres cubed, and my concentration 0.100 moles per decimeters cubed. Once I've got all of that information, I've got my balanced equation, I can fill in my moles table. So I have got my sodium carbonate, my HCl, my volumes, again, I've converted to decimeters cubed by dividing by 1000. My ratio I've gotten from my balanced chemical equation, and I'm able to work out the number of moles of sodium carbonate in 25 centimeters cubed. So again, I've written here that this is the moles of sodium carbonate in 25 centimeters cubed. As I said, I want to work out formula mass. I've now got moles, and in the question I've got grams, but just as before, I've got grams per 250 centimeters cubed, and from my titration, I've got moles per 25. Before I plug these numbers into my formula, I'm going to need them both per 250, or I could do them both per 25. I'm going to go them both per 250. So I know how many moles I've got in 25. To work out how many moles I've got in 250, I'm just going to be timesing by 10. So now I know the number of moles I've got in 250. I can therefore work out the formula mass of my sodium carbonate hydrated. Okay, so the whole thing has a mass of 2.86 grams. I'm given that in the question. The formula mass, the moles is 0.01. Therefore, the formula mass of the whole thing, including the water, is 286. I need to work out how many water molecules I have. I can do that by subtracting the formula mass of the sodium carbonate from the formula mass of the whole thing. Formula mass of sodium carbonate is 106. I can then take this 106 from the 286, and I'm left with 180. And the 180 must be caused by the molecules of water. However, we're asked to identify N, so how many molecules of water do I have if the total formula mass of water is 180? Well, each individual molecule of water has a formula mass of 18, therefore I do 180 divided by 18 and I get 10. I've got 10 molecules of water in this hydrated sodium carbonate. So even though it looks slightly harder, the process was exactly the same as before. We're trying to find formula mass. You're given mass in the question. You work out moles using your titration table, but before you plug them both back into the formula, you need to make sure they're both per the same volume. In this case, I've done both of them per 250. Once you know the formula mass of the whole thing, you can work back to find out the formula, N in this case. And in the example before, we worked back to find X.